Hello, welcome to Mechanical Engineering. In today's video, we are going to discuss the various milling machine operations, which are the various possible operations that we can perform over the milling machine. So the very first slide, that is introduction. So here you can see the image of vertical milling machine. So this is nothing but a vertical milling machine. So broadly we can classify the milling machine in two categories: vertical milling machine and horizontal milling machine. So here on the screen you can see a vertical milling machine. Now milling is the machining process of using rotary cutter to remove the material from the workpiece. So basically milling is a machining process. That means in milling process we are interested to remove the material from the workpiece, and how that material is removed? By using a rotary cutter. So milling is the machining process of using rotary cutter to remove the material from the workpiece. It covers a wide variety of different operations and machines on a scale from small individual parts to large heavy duty gang milling machines. So at the workshop you can see the small milling machine and even a large heavy duty gang milling machine which has multiple cutters. So at the same time you can remove the material by using multiple cutters. It is one of the most commonly used process in industry and machine shop for machining parts to precise size and shapes. So you are getting a part from the milling machine with a precise size and shape. Now the principle of milling machine. So milling operates on the principle of rotary motion. So basically milling machine consists of a rotary cutter. So it operates on the principle of rotary motion. A milling cutter is spun about an axis while a workpiece is advanced through it such a way that blades of the cutter are able to shave the chips of a material with each pass. So basically in milling machine, one milling cutter is there which spin about an axis. If you are using vertical milling machine, so that milling cutter will rotate about the vertical axis, and if you are working on horizontal milling machine, then the milling cutter will rotate about a horizontal axis, and then the workpiece is fed against the rotary motion so that the material is get removed from the surface of the workpiece. Axis of the tool rotation is perpendicular to the feed. So when you are using vertical machine, then the axis of the cutter is perpendicular, and if it is a horizontal milling machine, then it is parallel. Now this is an image of horizontal milling machine. So earlier to this slide we have seen vertical milling machine where, so this is vertical milling machine. Here at this point you can attach your milling cutter, and the axis of this milling cutter is perpendicular to the table. So this is the table axis. Here I am showing the table axis, and the axis of the milling cutter is perpendicular to your table axis. Whereas in horizontal milling machine, this is the horizontal milling machine. This portion is known as arbor of your horizontal milling machine. Over this arbor you can attach the milling cutter, and the axis of the milling cutter is parallel to the table axis. So that is the difference. Okay, so a horizontal mill has a same sort of XY table, but the cutter are mounted on a horizontal arbor across the table. Even in horizontal milling machine you can rotate this table. Now this is nothing but the table of the horizontal milling machine. This portion is known as table. Now in some horizontal milling machine you can rotate the table, and if you are able to rotate the table of the machine, then it is known as universal table. That is all about your horizontal milling machine. Now the vertical milling machine. So in vertical milling machine the spindle axis is vertically oriented. So here you can see this is nothing but the spindle of your vertical milling machine, and this is perpendicular to the table. So this is an axis, sorry, this is an axis of your vertical milling machine, which is perpendicular. Milling cutter are held in the spindle and rotate on its axis. So the milling cutter is held in the spindle. There are two subcategories of the vertical mill, the bed mill and the turret mill. Now we will discuss the various operations performed on the milling machine, which are the possible operations that we can perform over the milling machine. So first of all, I will list down the operations and then I will discuss it in brief. So the very first operation, that is plane milling. The second one is face milling. Third is side milling. Fourth one is side and face milling. Fifth, the straddle milling. Sixth, angular milling. Seventh, gang milling. Then the form milling. Ninth, profile milling. 10th, end milling. And the last one, that is saw milling. So here I have discussed 11 different possible operations that you can perform over your milling machine. Now we will discuss one by one operation in detail. So the very first operation, that is nothing but plane milling. So here you can see an image of plane milling operation. So this is a cutter and below that cutter there is the workpiece, and that workpiece is fed against the rotating cutter. So the plane milling is performed to produce a plane, flat, horizontal surface parallel to the axis of rotation of plane milling cutter. So here you can see the axis of rotating cutter and the workpiece, they are parallel to each other. So the plane milling is performed to produce a plane, flat, horizontal surface. That is the purpose of plane milling machine, plane milling operation. The operation is also known as slab milling. Plane milling is also known as slab milling also. To perform the operation, the work and the cutter are secured properly on the machine. So first of all, you have to clamp the workpiece over the table of milling machine, and then you have to fix the milling cutter. The depth of cut is set by rotating the vertical feed screw of the table. So how depth is given? You have to move the table of the milling machine in vertical direction. With that you can give the depth, and after that the feed is given. So that is all about plane milling. Second operation is face milling. The face milling is a simplest milling machine operation. This operation is performed by a face milling cutter rotated about an axis perpendicular to the work surface. Here the axis of the rotating cutter is parallel to the surface, whereas in face milling operation, here you can see the face milling operation, these are two different cutters and the axis of this cutter is perpendicular to the workpiece. That is the basic difference in between plane milling and the face milling. In plane milling, the axis of the cutter is parallel, whereas in face milling, the axis of the cutter is perpendicular. The next operation is side milling. So the side milling is the operation of producing a flat vertical surface on the side of the workpiece by using side milling cutter. The depth of cut is set by rotating the vertical feed screw of the table. So here you can see an image of side milling cutter. This is a side milling cutter, has a teeth over the side, and with this teeth you can remove the material from the side of the workpiece. So here in this image you can see from the side of the workpiece the material is being removed with the help of a side milling cutter. The next operation is side and face milling. Here we are combining the two different operations. In earlier slide we have discussed the side milling. Okay, before that we have discussed the face milling. Now here we are combining the two operations, that is side and face milling. So machining is done by the teeth on the flat as well as cylindrical surface of the cutter. Finished surface are perpendicular as well as parallel to the axis of the cutter. So here you can see the side and face milling cutter. The machining is done here you can see the machining is done with the help of these two teeth. Okay, so this is a side teeth and this is over the periphery, right? So with this teeth, with these teeth which are available on the side of milling cutter, we can remove the material from the side of the workpiece, and with these teeth which are on the periphery, we can remove the material from the surface of the workpiece. So with side and face milling, we can remove the material from the side as well as on the face. So here you can see this is a side and face milling cutter. The material is removed from the side of the workpiece. The material is removed from the side of the workpiece as well as from the face of the workpiece. So here we are combining two different operations in a single operation. At the same time, we can remove the material from the side which is perpendicular to the workpiece, and again you can remove the material from the face which is nothing but parallel to the surface of the workpiece. The next operation, that is known as straddle milling. The straddle milling is the operation of producing a flat vertical surface on the both side of the workpiece by using two-side milling cutter mounted on the same arbor. Distance between the two cutter is adjusted by using suitable spacing collar. The straddle milling is commonly used to design a square or hexagonal surface. So here you can see an image of straddle milling. So on the arbor you can see two different cutters. The distance between the cutter that can be changed with the help of collar. So here these two different cutters are removing the material from the side. Okay, so here you can see this is nothing but the side of this workpiece. These are nothing but two different sides of the workpiece, and the material is removed with the help of these two different milling cutters. Okay, this is known as straddle milling cutter. Again I am repeating, the straddle milling is the operation of producing a flat vertical surface on both sides of the workpiece by using two side milling cutter mounted on the same arbor. So at the same time we can remove the material from two different sides of the workpiece. Distance between the cutter is adjusted by using suitable spacing collar. So here the distance between the cutter that can be adjusted by using the collar. Here you can place the collar and you can adjust the spacing between the cutter. The straddle milling is commonly used to design a square or hexagonal surface. So with this you can produce a square or hexagonal surface over the surface of the workpiece. The next operation is angular milling. The angular milling is the operation of producing an angular surface on the workpiece other than at right angle of the axis of milling machine spindle. So here you can see the image of angular milling. So with angular milling you can produce the surface at any angle other than right angle. Okay, so if you observe a side milling operation, so you are getting a face which is perpendicular to the surface of the workpiece. But whenever you want to produce the surface which is not perpendicular, in that case you can use angular milling process, and with angular milling you can produce an angular surface on the workpiece other than at right angle. The angular groove may be single or double angle and may be of varying included angle according to the type of contour of the angular cutter used. So here we can produce the surface at any angle, and the angle is depend on the angle of surface of the cutter. One simple example of angular milling is production of V block. So here we are producing V block with the help of angular milling operation. So this is nothing but a V block. This is a V block, and this V block is machined with the help of angular milling cutter. We are getting same angle as that of your cutter. So simply you have to mount the angular milling cutter over the arbor, and then you have to give the feed against the surface, against the workpiece, and you can produce a surface which is at some angle This is all about the angular milling operation. Now the next operation, that is gang milling. The gang milling is the operation of machining several surfaces of a workpiece simultaneously by feeding the table against the number of cutter having same or different diameters mounted on the arbor of the machine. So this is very important and very interesting operation over the milling machine. So here you can see gang milling operation. So this is nothing but a schematic for gang milling operation. Now this is the arbor, and on this arbor different milling cutters are mounted, like plane milling cutter, side and face milling cutter. So over a one arbor you can mount number of milling cutters, so that at the same time simultaneously you can produce or you can machine number of surfaces. That is why it is known as gang milling cutter, because different cutters, they are working in a gang. So in this image you can see there are 4 different cutters, they are mounted on a single shaft. Okay, and but an image of gang milling machine. So here you can see the arbor of the machine. Now this is the arbor of the machine, and over this arbor these are different cutters, they are mounted. Okay, so these cutters are mounted over the arbor. Here you can see 5 to 6 different cutters, they are mounted over the arbor, and with this cutter you can simultaneously remove the material or you can machine the component. Now gang milling is the operation of machining several surfaces. So several surfaces you can simultaneously machine by feeding the table against the number of cutter. So the feed is given with the help of table. You have to move along x, y or z direction. Okay, so by feeding the table against the number of cutters, so number of cutters can be used having same or different diameters. Even you can use different diameter cutters. So here you can see the plane milling cutter has different diameter, whereas side and face milling cutter has different diameter. Okay, and they are mounted over the arbor of the machine. So this is all about the gang milling operation. Now the next operation is the form milling. The form milling is the operation of producing the irregular contour by using form cutter. The irregular shape may be convex, concave or of any shape. After machining, the form surface is inspected by a template gauge. Okay, cutting rate to a form milling is 20 to 30% less than that of plane milling. So this is an image of form milling operation. Okay, so the form milling cutter is mounted over the arbor, and you can produce a irregular shape with this operation. Okay, the operations we have discussed till this slide, with those operations we can produce only flat surfaces, we cannot produce irregular surfaces, whereas with form milling operation we can produce irregular surfaces. Suppose on this workpiece I want to produce a round surface, so that round surface can be produced with the help of form milling cutter, provided that form milling cutter should have the same shape whichever I want. Okay, so that is nothing but form milling operation. So here I can produce a round shape by using a form milling cutter. Okay, so once again I am repeating, the form milling is the operation of producing the irregular contour. So whenever you want to produce an irregular contour, you can use the process, that is form milling. The irregular shape may be of convex, concave or any other shape. After machining, you can inspect that surface by using template gauge. Okay, and the cutting rate for form milling is 20 to 30% less than that of plane milling, because here you are producing a particular shape or a particular surface, and for that you have to keep feed 20 to 30% less than that of your plane milling operation. The next operation, that is the profile milling. This is also one of the interesting operation that you can perform over the milling machine. So the profile milling is the operation of reproduction and outline of a template or complex shape of a master die on the workpiece. Different cutters are used for profile milling, and end mill is one of the widely used milling cutter in profile milling work. So with this image you can understand profile milling. So here you can see the die which is placed over the table of the machine, and this is nothing but the workpiece. Okay, so and there is one stylus. Okay, I will clear this first, and now we will see. Now this is nothing but your master component. Okay, and this is the workpiece, and you want to reproduce this component. Okay, so one stylus is there. This stylus is guided by this is nothing but the stylus. Okay, this stylus is guided by this master die. Okay, and then the movement is followed by this cell. Okay, so you can reproduce the component. This is the master component, this is the workpiece. The same operation you can perform over the workpiece, so you will get same job. Okay, and that is the purpose of your profile milling operation. So the profile milling is the operation of reproduction and outline of a template. Okay, so this is nothing but the template. This is nothing but the template. Okay, this is a template that you want to follow, right? So the profile milling is the operation of reproduction and outline of a template or a complex shape of a master die. Okay, so whenever you want to produce a complex shape, you can go for profile milling operations. And over the profile milling machine or during the profile milling operation, you can produce various types of cutter, but mostly end milling cutters are used. Now the next operation is end milling. The end milling is the operation of producing a flat surface which may be vertical, horizontal or at any angle in the reference to the table surface. So here you can see the end milling operation, and this is nothing but end milling cutter. Okay, which is quite similar to your drill bit, but drill bit has a pointed end, whereas this has a flat end mill. So end milling is the operation of producing a flat surface which may be vertical, horizontal or at any other angle. So here with this operation you can produce a flat surface. The cutter used is the end mill. The end milling cutter are also used for the production of slot, grooves or keyways. So with this you can produce a slots, keyways or the grooves. A vertical milling machine is more suitable for end milling operation. So mostly end milling operation is performed over a vertical milling machine. The next operation, that is saw milling. Saw milling is the operation of producing narrow slots or the grooves on the workpiece by using saw milling cutter. The saw milling also perform for complete parting of operation. The cutter and the workpiece are set in a manner so that cutter is directly placed over one of the T-slot of the table. So here you can see the saw milling operation. So the cutter is mounted over the arbor. Okay, and this is the workpiece. Okay, so here I am showing this is your cutter, right, and this is the workpiece which is placed. This is nothing but the workpiece which is placed over the table. Now you can use this saw milling cutter for parting of. Okay, you can break this workpiece in two pieces. So it is kept over the table, and then your cutter is mounted such that it is exactly over the T slot, because it has to pass through the table. And how it can pass through the table? The milling cutter has to pass through the T slot. Okay, So that you have to understand. So saw milling is the operation of producing narrow slot or the grooves on the workpiece. So with saw milling you can produce a narrow slot over the workpiece, or you can break that workpiece into two pieces. But whenever you want to break that workpiece into two pieces, that time you have to place the cutter exactly over the T slot which is provided in the table of the milling machine. Then and then that can pass through the table of the machine and you can break the workpiece into two pieces. So this is known as saw milling operation. So that is all about in today's video. So in this video I have discussed two basic types of milling machine, that is horizontal milling machine and vertical milling machine, its difference and the various operations that you can perform over the milling machine. Thank you so much for watching my video. Thank you.